So this particular class I want to discuss, because till now we discussed how to arrange the things in a line. Now I am going to discuss how to arrange the objects in a circular manner. That is the discussion we are going to do here. Before going to discuss that particular question, this is the word given again. A word again given. By using the letters of the word again, total 5 factorial divided by 2 factorial, you will get 120 by 2, 60 words you will get. All these 60 words arranged as in a dictionary. What is 50 word? 50th word we have to find out. So total with the help of these letters, you will get 5 factorial divided by 2 factorial words are possible. All those 60 words if you arrange as in a dictionary, what is the 50th word? That we have to find out. Okay, see here. Again, first of all, the number of words that begin with A, because alphabetical order, agree or not? A, G, I, N, that is the alphabetical order, right? Number of words that begin with A is equals to 4 factorial. Number of words that begin with G is equals to 4 factorial divided by 2 factorial. Number of words that begin with I is equals to 4 factorial divided by 2 factorial. Whether you observed or not, 24 words completed with A. Again 12 words completed with beginning with G. 12 words completed beginning with I. Total 48 words over. The next we have to go for N, right? So that's why N, A, I, G one possibility, N, A, G, I another possibility. This is the order. N, A, G, I is one possibility, that is 49th word. N, A, I, G is the next possibility, that is the 50th word. That's why the 50th word is given by N, A, I, G. So that is the 50th word. By using the letters of the word again, if you arrange all the letters, you will get the words. Those words if you arrange as in a dictionary, the 50th word is given by N, A, I, G, right? So let us discussion of very important idea, circular permutation. So you know very well, n objects can be arranged along a line in n factorial ways. But the same n objects I want to arrange in a circular way. The same n objects I want to arrange in a circular way. What about the different ways? So observe here, n objects we want to arrange in a circular way. These are the n distinct objects. One is A1, A2, A3, A4 and A5 and so on. We can say it is A n minus 1. Here we have A n minus 2. N objects can be arranged circularly in how many ways we don't know. Let us say n objects can be arranged along a circle in x ways. Okay, the number of possibilities is equal to x, I am assuming. Among those x possibilities, this is one of the possibility. A1, A2, A3, A4 and so on up to An minus 1. That is one of the possibility. This single possibility will give us, this is A1, A2, A3 and so on, An minus 2, An minus 1. Next A2, A3 and so on, An minus 2, An minus 1, An. Sorry, here up to An. total n persons. So an minus 1, next a1 will come. See, first the line start with a1, next the line start with a2, that's why up to here. Next the line may start with a3, a4 and so on, an minus 1, an, a1, a2. If you continue like that, you will get an, a1, a2 and so on, an minus 1. So line may begin with a1, line may begin with a2, line may begin with a3 and so on, line may begin with an. Array one circular permutation gives us n linear permutations, permutation along a line. But 1 is giving n means definitely x will give x into n, right? Once again, so I am assuming n objects can be arranged along a circle in x ways, because we don't know, we are assuming x ways. Among those x possibilities, this is one of the possibility, a1, a2, a3, a4, a5 and so on up to an. That is one of the possibility. That one possibility giving us, this is one linear permutation, this is another linear permutation, line beginning with a2, line beginning with a3, line beginning with an. Like that, one circular permutation gives us n linear permutation. One is giving n, x will give nx linear permutations. But we know n objects can be arranged along a line. N objects taken all at a time can be arranged along a line. In how many ways? We can arrange it in np n ways. Nx is equal to npn. Therefore, we can say x is equal to npn divided by n, that is equals to n minus 1 factorial into, because npn is equal to n factorial divided by n factorial can be written as n into n minus 1 factorial by n cancel, we are getting n minus 1 factorial, right? So n distinct objects can be arranged in a circle in how many ways? npn by n, that is nothing but n minus 1 factorial. Array n distinct objects taken n at a time can be arranged in a circle in npn by n ways. Now I am asking, n distinct objects, right? But we are taking r at a time. Out of n, r at a time and arrange circularly in how many ways? So n distinct objects taken r at a time can be arranged circularly in npr divided by r. But now the question arises, in a circular permutation where there is no significance for clockwise and anti-clockwise directions. You can observe one of the example I am taking here. This is a1, a2, a3, a4, a5. a1, a2, a3, a4, a5, they are in clockwise direction. Now observe here, a1, a2, a3, a4, a5 in clockwise direction. The same here I am taking a1, a2, a3, a4, a5. Here the same order, but they are in anti-clockwise direction. So a1, a2, a3, a4, a5 is in clockwise direction. Here they are in anti-clockwise direction. So where there is no significance for clockwise and anti-clockwise directions, in that case these two arrangements we can take it as same. You see, you are holding a garland like this, flower garland. You are holding the flower garland or necklace like this type of things, gold chain. You are hanging the garland like this. Whether you are hanging like this or you are turning it in this way, it makes no difference. That's why in case of garlands, that means where there is no significance for clockwise and anti-clockwise directions, number of permutations becomes exactly half, because these are two different cases. When there is no significance for clockwise and anti-clockwise directions, these two becomes same only. That's why the number of circular permutations you will get in that case npn divided by 2n, that is nothing but n minus 1 factorial divided by 2. Whereas the second case npr divided by r divided with 2. That's why npr divided by 2r. That is the answer where there is no significance for clockwise and anti-clockwise directions. So one more example here I am taking. So where there is no use of clockwise and anti-clockwise directions. Suppose here 5 members, they came for a dinner. They are sitting in a round table for dinner. You see, either in this case or in this case, they have in this seating arrangement or in this sitting arrangement, in each of the person have the same neighbors or not? Tell me here, who are the neighbors for A1? A1 neighbors are A2, A5. Who are the neighbors for A3? A3 neighbors are A2, A4. Who are the neighbors for A4? A4 neighbors are A5, A3. Here also A4 neighbors are A5, A3. Here also A1 neighbors are A2, A5. Here also A1 neighbors are A2, A5. So when he is asking in a question, so where in each arrangement they don't have each of them, they don't have the same neighbors. Number of sitting arrangements for a dinner such that they don't have same neighbors in each arrangement. Either in this case and in this case they have the same neighbors. So in that case also we have to divide with 2. So that is about the discussion regarding circular permutation. Just to see one of the question he is asking, there are 7 Indians and 6 Pakistanis. They are sitting in a round table, so that no Indians sit together, no 2 Indians sit together. What is saying? 7 Indians, 6 Pakistanis sit in a circular table. The number of different arrangements such that no 2 Pakistanis sit together. Okay, first of all, arrange 7 Indians, I1, I2, I3, I4, I5, I6, I7. 7 Indians can be arranged in a circular way in how many ways? 7 minus 1 factorial ways. Once in a circular permutation arrangement done means the next whatever we are doing, it is just like line only. So that's why 7 Indians arranged in a circular way in 7 minus 1 factorial. Now these are the gaps to fill Pakistanis. How many gaps are there? How many gaps are there? 1, 2, 3, right? 1, 2, 3, 4, 5, 6, 7 gaps are there. 7 gaps can be filled with 6 Pakistanis in 7p6 ways. Once in a circular permutation, once arrangement is over means next again we are filling in those gaps means it is just like linear permutation only. These 7 gaps can be filled with 6 persons in 7p6 ways. So that is the answer for this particular question. So let's take another question. 20 persons are invited for a party. 20 persons are invited for a party. There are 2 special members are there. There are 2 special members are there. They have to sit. They have to sit both side, either side of the host. Total 20 persons are invited for a party. Let us say this is his host. Now we have to keep here 1 seat, here 1 seat. Total 20 persons are invited for a party. Now here one special guest we have to leave the place. For here one special guest we have to leave the place. So number of different arrangements he is asking. Now I am considering this box as 1 unit because 20 members are invited for a party. So H we can't consider, host we can't consider among 20. Host is a special one. So now remaining 1, 2, total how many are there? 18 are there. Yes or no? Like this total we have 18 more members are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that total 18 more members are there along with these two special invitees. Okay, we are considering this as one box, right? 1 plus 18, total there are 19 units can be arranged circularly in 19 minus 1 factorial ways. 19 units can be arranged in a circle in 19 minus 1 factorial ways. After arranging them circularly, what to do? Now these two special guests can interchange their places or not? They can interchange their places in 2 factorial ways. So that is the answer for that particular question. So let us see another question they are asking like this here. 7 members we want to arrange for a dinner. The number of different arrangements so that they don't have same neighbors in each member. They don't have the same neighbor in each arrangement. So that's what, as I told in the earlier example also, we can write directly 7 minus 1 factorial divided by 2, right? Because where there is no significance for clockwise and anti-clockwise direction, we have to divide with 2 factorial. Okay, bye bye.